Are we able to invest today? We want to invest, but is it ready? Can it make it cheap enough and economically enough? Would the market be ready for this kind of thing? So in ASEAN, I think all of us know cheap is good. Right. So let us hear from Mr. Steenken. What do you think about Dato's views about this economic viability of technologies? What is suitable for ASEAN? Please give us some insight.
Unfortunately, I must admit I don't have the crystal ball. I cannot predict what is going to happen, but good news, at least from a technological standpoint, the technologies are there to produce low emission or even emission-free steel. So, I mean, whenever looking into the challenges, the challenges, of course, are mainly upstream. I mean, we are discussing here de-greening of the steel industry, and that's actually the big challenge to tackle. And when we are looking, let's say, from a global perspective into the situation and into the challenges, somehow if we calculate, if we merely make the math on high level, it's somehow not going to work out. It will be very, very challenging to meet and comply with the targets we all over the world have given ourselves. Just some simple examples. Looking into iron ores. I mean, for the current DRI process, we are usually relying on high-grade iron ores. When we are looking into the global availability of high-grade iron ores, we are somehow coming to a limit. And the limit always means price increase. So that's a big challenge, and that we definitely need to solve. And luckily, we have developed some technologies to at least tackle that challenge. Another challenge, of course, scrap. I mean, scrap is not the only solution. We can build as many electric arc furnaces as we want to. Without scrap, scrap is something we cannot mine, we cannot dig out of the ground. There will be not enough supply available. And again, we see already what is happening to the scrap prices here in Southeast Asia. They are peaking. So scrap is also not the only solution. Blast furnace, that's something that is going to happen here. We are de-greening, more and more blast furnaces coming up. And actually that's one of the key challenges that we took. I mean, whenever talking about decarbonization, it's not only about the big green steel mills that are built in Europe, it's also about decarbonizing the blast furnace. And there's actually where we as SMS put a lot of R&D into to really decarbonize the blast furnace. But long story short, at the end, from my perspective, the biggest challenge we are facing, and where I'm even not agreeing how Europe is tackling it, is the availability, we're also addressing it, of cheap green energy. That's the challenge we are having, because technology is there. What do we need is cheap green energy, and we need a lot of green energy just to cope with the CO2 targets we are having. We would need 80% of the global available renewable energies just to decarbonize our industry. So that is somehow not going to work out. We need definitely more cheap green energy, because that is at the end the basis for whatever we are discussing. Because what is hydrogen at the end? It's conversion of green electrical energy into hydrogen. So again, we are very much depending on the electrical price of the energy, and also of course the availability. And then also another challenge, if we are looking into the global perspective, just to comply with the targets all the countries have given themselves, we would need to decarbonize 40 million tons per year. Just see how many projects are under development, and also now in Europe we see it's slowing it down a little bit. So this transition speed and also capex required, I mean, we are talking about trillions of dollars that are needed to decarbonize our industry. And therefore, we're having slightly different perspective on the thing. It's not only about electric arc furnaces. Electric arc furnace is available, AC, DC technology. It sounds like a rock band, but it's these two technologies are available, market proven. Of course, DC with a little lower carbon intensity. DRI is market proven, available, but of course DRI needs either cheap green hydrogen, mostly not available, or we need natural gas, mainly here not available to large quantities for cheap prices. And even with natural gas, of course, we are not carbon neutral. And therefore, again, we invested so much money into blast furnace at the moment to convert the blast furnace into a nearly carbon free asset. So that is, I think, from my perspective, the key changer or game changer for our industry. It will be an add-on. Of course, electric arc furnaces are part of the future, DRI plants are part of the future, but also the green blast furnace is definitely, from my perspective, part of the future. And the blast furnace of the future will look slightly different. We have now a very nice project under execution, surprisingly, in India. So India is also making up their minds how to tackle this challenge, because there is a very young blast furnace fleet, lots of blast furnaces coming into operation. And our concept is to stepwise decarbonize the blast furnace. So in step one, we are introducing a second ring on top of the current 2-year level and injecting syngas. Syngas can be produced and generated by many different ways. Also hydrogen, or maybe even more important, direct use of ammonia, because the big problem with hydrogen is you need to carry it from A to B in most of the cases. And whenever you have to convert it from hydrogen into ammonia back into hydrogen, you have conversion cost, and that is killing at the end the business case. And therefore we have developed the technology to directly use ammonia in a blast furnace. We only have to heat it up, we have to crack it, can inject it in the blast furnace. And then in the second stage, we are actually converting the blast furnace. It will not be a blast furnace anymore. We call it easy melt because it's a very nice mix of all technologies available. Electrical energy, so we are electrifying the blast furnace. We are replacing the hot stoves by plasma torches, 2,200 degrees Celsius. Energy, electrical energy needed, of course, to bring in then the heat into the process. And the reducing agent will be injected via the second ring of the syngas. And this is, from my perspective, one of the key add-ons we definitely need, and that's also something ASEAN should consider whenever implementing, installing new blast furnaces. And it's the same way we do it in India. They are all future ready. So they operate still in the beginning in the old way, and later on we can replace or add the syngas injection, and one day also replace the hot stoves via plasma torches. And that is now implemented in India. And the good and the very, very interesting thing is, of course, it's not as capex intensive as building a new plant. Plus the OPEX is even superior based on what we have seen now on the calculation compared to the conventional process. And that is, for me, the big game changer. It's not only capex, it's also in terms of OPEX, if I check it. That's what we are working on as a technology supplier.
Thank you very much. So it's